Hello everyone. So in this video we are going to discuss another important reaction of phenols, that is the esterification reactions. As we had seen in the case of the alcohols were able to form the esters on the reaction with carboxylic acids, with acid anhydrides and with acid chlorides. Similarly, phenols also react with these acids to give the corresponding esters, but the reaction of phenols to form the esters is a little bit not that much effective as it was in the case of alcohols. They are less reactive towards the esterification reaction. Particularly, phenols do not react with, or we can so say that they react very slowly with the carboxylic acids. Okay, so we are going to take the reaction of phenols with acyl chlorides, which is also called as acid chloride. Okay, this is also called as acid chlorides. Okay, it belongs to the group of acids which you call as acid halides. Okay, acid halides, we have acid bromide, we have acid iodide. Okay, so the acid chlorides react with the phenol and we get the corresponding ester, and the reaction takes place at the room temperature. So when phenol reacts, we are taking the example of ethanol chloride. We have taken the ethanol chloride. This is CH3C double bond OCl. Okay, so we have two carbons. When we name it, so we'll be naming it as ethanol chloride. If we have two carbons, if we have three carbons, then it will be propanol acid. If there are four, then it will be butanol acid, butanol chloride, and so on. Okay, and in this reaction of phenol with the ethanol chloride, we're getting the phenyl ethanoate. We're getting the phenyl ethanoate. This is phenyl ethanoate. Again, we have two carbons. That's why we call it as ethanoate. It's phenyl. We have phenyl ring attached to the ethanoate group. That is why it is the phenyl ethanoate. Okay. We also call it as by the general name, that is phenyl. It's phenyl acetate. It's also called as phenyl acetate. Okay, so this reaction is carried out in the basic medium. We use a base for the reaction. The base does the work that it abstracts the proton from the phenol, and we get the corresponding ester. And in this case, we also get hydrochloric acid as a byproduct. Okay, so the reaction is simple. We'll be looking at the mechanism of this simple reaction. Okay, so what happens? We have a phenol. This is a phenol, O, and this is the H. Okay, so what happens in the first step of the reaction? We are using base, and we should remember that the base that we use mostly is the pyridine. Okay, this is the pyridine. We use the pyridine as a base. So base abstracts the proton from the phenol. Okay, and in this reaction we get the phenoxide ion. We are getting the phenoxide ion as a reaction intermediate. Okay, so we have this phenoxide ion, and we're losing the phenol is losing a proton. This is losing a proton which remains in the reaction medium. So in next step, what we do, we add the acid chloride. For example, where we are adding the CH3C double bond OCl to the reaction system. Now we know that this bond C double bond O, this is a polar bond. We have a small positive charge on this carbon, we have a small negative charge on this oxygen. So now this bond is polar, and when we mix it in the reaction medium, what happens? This negatively charged oxygen, this attacks the carbon with the positive charge. As a result, this electron pair moves towards is kicked up to the oxygen, and as a result we get a product like this in the step. Okay, so we have phenol, we have this phenoxide ion. Now O is attached to this carbon. Okay, and we have a negative charge, this electron pair on the carbon, and we have chlorine and CH3. Okay, as we know, the chlorine is a good leaving group. Okay, now what will happen? This electron pair goes back to the carbon, between the carbon and oxygen, forms a pi bond, and this this chlorine is kicked out. Okay, why? This is a good leaving group. As a result, it leaves easily. And what happens? We get our final product. This is the final ester that we are getting in the reaction. So we have O C double bond O, C double bond O, and CH3. Okay, so this is our final product. This is the phenyl acetate that we are, or phenyl ethanoate that we are getting in the reaction. This is the product. And now this Cl negative and this Cl negative that's present, that we have obtained in this reaction, okay, in this step. Now this reacts with the hydrogen and we get HCl, we get hydrochloric acid as a product, as a byproduct in the reaction. Okay, so we have a very simple reaction mechanism. In the first step, the base abstracts the proton. Okay, why? When we add base to an acid, the acid base reaction occurs and the base abstracts the proton, leaving behind the negative charge on the other species. Okay, so we have obtained the phenoxide. This is the phenoxide ion that we have obtained, and the phenoxide is capable of reacting this to this carbonyl carbon. Okay, so we have this as the final product. Similarly, we have the reaction of phenols with acid anhydrides. So this is again esterification reactions. Phenols react with acid anhydrides, and in this case we get two products. We get an ester, and in addition to this we also get a carboxylic acid. As we had seen in the case of alcohols also reacted with acid anhydrides, and there were two products, that's an ester and the carboxylic acids. Similarly, here also we get two products. Okay, here we have an example. The phenol reacts with ethanoic anhydride. This is ethanoic anhydride. We can have different number of carbons attached to across this oxygen. Okay, here in this case we have 2, 1 and 2, and also here we have 1 and 2. Therefore we give it the name ethanoic acid, and if the number change, then the name also change. So we have taken the example of ethanoic anhydride, the simplest one, ethanoic anhydride. And in this case we get the phenyl acetate as a product. Phenyl acetate, that is the phenyl ethanoate, also called as phenyl ethanoate. And we also get the carboxylic acid, that is the ethanoic acid. Okay, so again here the mechanism is very simple. It's not a complicated mechanism. So what happens, we should remember in this case also the reaction takes place in the basic medium. Okay, in the basic medium. So what happens, we're taking a phenol. So a phenol, first of all, there is a acid base reaction, that is the base we are using a base, and we should remember that the base we use in this case also is the pyridine. It is a pyridine. Okay, so this is the acid base reaction. It will abstract the proton. This electron pair will move towards the oxygen, and in this case we will be getting the phenoxide ion. This is the phenoxide ion that we are getting in this case, and we have we lose a proton in this case. This proton will remain in the reaction system. Okay, we can also do this reaction in presence of sodium hydroxide or a metal. If we react the phenol with the sodium hydroxide, we'll be getting phenoxide ion in that case also. But in that case we have to do a acidic work at last. But this is a simple mechanism. So we're using a base that will abstract the proton, and we are getting the phenoxide ion. This is the phenoxide ion that we are getting. So what happens in the next step, we have an acid anhydride. We will be taking an acid anhydride. We have CH3C double bond O. This is the acid anhydride that this is simplest one that we are showing here. So there is the attack of this phenoxide ion. Since we have a negative charge on this oxygen, it will attack on the carbonyl carbon, because as we know, this carbonyl carbon this bond is polar. So we have a del positive charge, we have small positive charge on these carbonyl groups. So the phenoxide ion will attack at any of the two carbonyl compounds. So what happens, this will attack the carbon, and this electron pair will be shifted up to the oxygen, and we'll be getting the intermediate product like this. So this is the ring, it will be attached to oxygen that's attached to this carbon. Then we have O negative, this is CH3 group, and rest part is same, it's unchanged. Okay, now this ion that we have obtained in this case, this is an unstable one, and there is a capability of this electron pair to move back towards the back and form a pi bond between the carbon and oxygen, and that in that case also the compound will be stable one. And since this is a very good leaving group, as in this case, so this electron pair will move, this will leave, and we'll be getting the ester as the product. This is the ester, CH3. This is the ester, this is the ester that we are getting in this case. Okay, so this is the product ester that we have got. But in the reaction system we have obtained now this ion, this is the leaving group that we have lost from this intermediate. This is the ion that is OC double bond OCH3. So we have a negative charge on this oxygen, and we have, as I already said, the reaction medium contains this proton. So this proton will be attached to this carbon. Okay, will be attached to this carbon because it is the positively charged. Okay, and this will attach, and we'll be getting the carboxylic acid. This is the second product of the reaction, that is the carboxylic acid. So this is the product A, that's ester, and this is the product B, that's the carboxylic acid that we have obtained from the reaction of phenol with the acid anhydride. Okay, we can have different types of acid anhydrides that we can use, and we'll be getting in different anhydrides, will be getting different esters and different carboxylic acids. Okay, so this is the simple mechanism of the esterification reactions that we have studied. So in the upcoming videos we'll be discussing other reactions of phenol.